Hey everybody, welcome back for another lesson in Algebra 2. We are in our first unit, which we basically are calling the fundamentals of algebra. In our last lesson, we were looking at sets and subsets and intervals. And before that, we looked at solving linear equations. So now we're ready to solve linear inequalities who have solutions that are intervals. So we'll be able to use our sets and our intervals to describe these solutions. So let's just dive right in it, okay? Example 5.1, solve the following linear inequalities. Graph the result on a number line and describe the intervals of the solution. So I'm going to solve this inequality. And when we're solving a linear inequality, it's basically going to work the same as a linear equation, but we need to remember a little trick. And that is that we always flip the direction that the inequality is facing, which I like to call the alligator, if we ever multiply or divide on both sides by a negative number. So if what you do to both sides is multiplication or division, and that what you multiply or divide by on both sides is negative, you need to flip the sign. All right, well, let's get to this first one. What I'm going to do is use a distributive property here. Okay, and then I'll just combine like terms. Now I'll add 3 to both sides. And I'll divide both sides by 5. I'll go ahead and show that step. And I end up with x is greater than 3. So we know that x greater than 3 means I have an open endpoint at 3. And all the values greater are over here. Okay, so let's describe the intervals of the solution. So there's a couple different ways we could do this. We could use set builder, right? We know how to do that now. We could say x such that x is greater than 3. We could also use our interval notation and put an open endpoint at 3 and then put infinity. So either one of these answers would be okay unless, the instructions specified that we have to use interval notation. And there we have it. All right, let's go into our next example. All right, on letter B, we have to distribute. Let me get back my pen. 7 minus 6x plus 3 is greater than or equal to 28. All right, now I'll combine like terms and I get 10 minus 6x is greater than or equal to 28. I'll subtract 10 from both sides. And I get negative 6x is greater than or equal to 18. Now I'm going to divide both sides by negative 6. So here's that situation we were talking about. I'm dividing on both sides by a negative number. Do you see that? The value that I'm dividing by is negative. It doesn't matter that the 18 is positive. What matters is that I'm dividing on both sides by a negative. So I have to flip the direction of the inequality, and I get negative 3. And because it's less than or equal to, we'll be coloring it in, making it a closed endpoint. And then we're going to shade to the left because we're looking at values less than or equal to negative 3. And so, that's the wrong thing. Let me erase that. So in interval notation, we could say negative infinity to 3 with a closed bracket at the end. All right, let's take a look at letter C. Okay, here we have an OR statement, right? So we're going to have possibly 2 different regions, And when dealing with this, I'll simply solve these as if they're two different problems. And I'll divide both sides by 2, and I get x is less than 2. So I'm going to go over here at 2, and then I'll color to the left. Now, you have to be careful with these OR statements because sometimes one of them can be redundant. Like if I said, I want all numbers greater than 10, or all the numbers greater than 20. Well, 20 is already greater than 10, so that's redundant. So you want to be careful about how you state your solutions. And that does happen sometimes, although that's not going to happen here. Okay, we get x greater than or equal to 5. So, I didn't really give us enough room here, did I? Colored that 5. And all right, I'm notorious for giving number lines that are pre-numbered that don't have enough space. So you feel free to just scratch those out or count by 2s or make it work somehow. That's totally fine. All right, let's do this one in interval notation again. And then I'll say union. We get to connect that word or in the union to 5 to infinity. Now you may be wondering, well, how would we say this in set builder notation? Well, it's going to look a lot like this, but with this word or in the middle. So if in set builder notation, we start with our set notation. We say x such that x is less than 2 or x is greater than or equal to 5. And you'll see some people that will use the union symbol here or something similar to it instead of saying the word or. I usually say or. Both are acceptable, of course, just a matter of personal taste. But I usually use the word or in set notation and the union symbol when using interval notation. All right. Do I get a break yet? No, I still got to do one more before y'all get to do some. All right. Okay, well, this is an and. I want to point that out, that this is an and statement here. You can combine and statements as long as there's two things in the middle. So I want you to realize, and I'm going to erase this so I don't want to confuse our work, but I want you to make this connection, that this is saying negative 5 is less than or equal to 2x plus 1, and, because those are our two operators, our and or, and 2x plus 1 is less than 9. So it's saying that both of these statements have to be true, but because we have the same value, we can kind of squeeze this together. Okay, and that's what they've done. They squeezed it together. But I think it's important to recognize that this really is two problems. It's just that I'm going to be solving it two problems at once. Since I'll be subtracting 1 on both sides for each problem. You know, for the problem here on the left, I'm going to solve by subtracting 1. The problem on the right, I would subtract 1. So I just subtract 1 at all 3 places. Little fancy math footsteps there. All right. Now I'll divide by 2 in all 3 places. And again, it doesn't matter that this 6 is negative. I'm dividing in all 3 places by a positive 2. Therefore, I'm not going to flip the sign. Okay, so we have negative 3 with less than or equal to x. So it's going to be closed in. And then x is less than 4, so I'm not going to close that in. And I'll color these in between here. And so in interval notation, this would look like negative 3 to 4. And if you're wondering, this here, if I want to make this in the set builder notation, I just put an x such that right in front of that statement. And then I've got it. Okay, now it is time for you to do some problems. So pause the video, work practice 5.1. You got quite a few problems. We will meet back and talk about it in just a sec. All right, let's see how you did. So on this one, let's see, we had to distribute a negative 3, right? So 2x minus 3x minus 3 is greater than negative 3. It gives me a negative x minus 3 is greater than negative 3. I'll add 3 to each side. Negative x is greater than 0. All right, so then I divide both sides by a negative 1, right? So if I divide both sides by a negative 1, I need to flip the direction of the alligator to face the left. So this is an open endpoint at 0, and it goes to the left. So our solution interval is -infinity to 0. All right, let's see about the next one now. Let me just scoot this up a little bit here. Okay, so I've got 4x minus 7 is less than 1. So I'm going to add 7 to both sides. I get 4x is less than 8. Divide both sides by 4. I get x is less than 2. All right, on this one here, I'm going to divide both sides by a -3. And because I'm dividing by a negative, I need to flip the direction of the inequality. And there's an or. So we'll be doing both of these. So I have x less than 2. So that's like this. Or x is less than or equal to -2. Oh, that's the redundant one. We talked about that. So it turns out that, a simplified solution set in set interval would be like, in set builder notation would be like so. All right? Or in interval notation, just -infinity to 2. So you need to be careful of that because a lot of times that happens, specifically in application situations. We really want to make sure that we give the best answer possible. All right, let's go on. See what else is there to do. Looks like a couple more, and then we're going to go into something a little bit different. We're going to throw a wrench in this thing here. All right, let's see this last couple problems from the practice. All right, let's distribute the -9. All right, I'll combine 4x and 9x and get 13x. I'm going to subtract 4x from each side, making this 9x. All right, in case you're trying to see, that's me doing this right there. Then I'll add 9 to each side and divide by 9, and I get x is less than or equal to 2. So that's the colored in circle, and it goes this way. So my solution interval is -infinity to 2 with a hard endpoint. All right, let's try the last one here. We have an and. Okay, so why is it not squeezed together? And well, the reason why is because these are not the same. -x plus 5 and 2x, they have to be the same for me to squeeze them together. So we have to solve this one in 2 different ways, and then we can squeeze it together at the end. So I have 3 less than or equal to -x. Let's divide both sides by a -1, and because I'm dividing by a negative, let me make that clear. I'm dividing by a -1. Okay? So because I'm dividing by a negative number, I must flip the inequality. I get x is less than -3, right? Remember, alligator eats the bigger amount, so it's not eating the x, so I need to go left. I don't know if you ever heard that. That's kind of fallen out of favor in math circles, but I grew up with this thing here being an alligator, and it always, whatever it's eating is bigger than the other one. Okay, so, and we still have this and here. We're going to divide both sides by 2, and I get x is greater than or equal to -5. Okay, so that is at -5 and going this way. I think it would be possibly helpful if I did this in 2 different colors. So let me show that one. So that's this way going that way. But because it's and, it's only where it's happening twice. So it's this point in between the two. And I think it's easier to figure that out if you go ahead and take this and squeeze it together. So because we have x in the middle, put x there. Put the smaller number on the left, the bigger number on the right, right? -5 is smaller than -3. And, let's see here. We were eating the -3, and we were eating the x here. So, and these things have to go in the same direction. If they're not, then you have something weird going on, or you've messed up, or the problem is got no solution. So this is -5 to -3 as my solution interval. And if you're putting it in set builder, I do want you to squeeze it together like we did there. All right, so I know I threw you some curveballs there on the practice problems, but that's giving you an opportunity to be a real mathematician, because in real mathematics we are constantly having to deal with new situations when they come up, figure out a way to solve them. So think, explore, and guess, and that's what the practice problems, right? They're not going to hurt you. Okay, glad we had that talk. All right, moving on. Okay, so we're going to solve the following inequalities over a domain of the natural numbers. So remember, I said earlier that our domain in this class will always be the real numbers unless I say otherwise. So I am saying otherwise. What are natural numbers? They're 1, 2, 3, 4, 5, etc. Okay, well, let's solve this over that domain. So I have 7 plus 2x plus, I'm going to distribute the 3. All right. And 7 minus 3 is 4. 2 plus 3x. 2x plus 3x is 5x. Subtract 4 from each side, and I get 22. I'll divide both sides by 5, and I get x is less than 22 over 5. Well, what is 22 fifths? You know, we don't usually like to put things in mixed numbers in math class, but this might actually help. So 22 divided by 5. 5 goes into 22 4 times. 4 times 5 is 20. So it's a 4 and 2 fifths. You know, that's what this number here is, okay? 4 and 2 fifths. But I said natural numbers. So I want to know all the natural numbers that are less than 4 and 2 fifths. Because this is a finite set and a relatively small one at that, I'm going to just list them in set notation. You know, they're discrete items. You know, I can just list the numbers separated by a comma. When we're dealing with intervals, I can't possibly list all the numbers from, like, say, 1 to 5, because that would be, there's an infinite number of them. But the number of natural numbers that are less than 4 and 2 fifths is not that big. The first natural number is a 1. 2 is the next natural number, then 3, then 4. 4 is definitely less than 4 and 2 fifths. But the next one would be 5, and that's too big. So that's it. That's our solution. 1, 2, 3, 4. All right, let's try another one. Okay, let's see here. I think I'm going to move the 5x over to the other side. That looks good. Get all the x's on the left here. So I have a negative x is less than 6. I'm going to have to divide by negative 1, though, because I got a negative in front of the x, so it becomes x is greater than negative 6. So let's draw a number line. I think some of you right now are probably yelling at the screens, telling me the answer, but I think this one's kind of tricky to think about. So there's 0, negative 1, negative 2, and here's 1, 2, 3. Remember, we're solving for a domain of natural numbers. So my natural numbers start here, and that's 1, and then 2, 3, 4. And we're being asked to find all the ones that are greater than negative 6. Well, negative 6, I didn't make it big enough, but it's, over here somewhere. All the ones that are bigger. Well, frankly, that's all of them, isn't it? So how are we going to describe that? Well, we just simply can use there's already a pre-built set notation for all the natural numbers. It's the double strike in. So I make these 2 lines, and then don't put that in set notation. That already is a set, okay? That is the natural numbers. This is equal to, if I was to do it 1, 2, 3, 4, and I'm going to run out of time before the end of the universe if I try and write all that, but you get the idea. But we don't have to say all that. We could just say the natural numbers in this case. So I'll take them out, because that's a pretty answer, and I want to leave it that way. All right. You have a couple more problems before your exit ticket. So would you please pause the video, work practice 5.2 right now. Again, we're dealing with natural numbers, and then unpause the video when you're ready, and we will check your work. Okay, so hopefully you had some success. Let's see what we can do here. I would distribute the negative 2. Let's see here. That becomes a 1 minus 2x is greater than or equal to 10. Subtract 1, and I get a 9. I'll divide both sides by a negative 2, and I get x is less than or equal to negative 9 over 2. So what natural numbers are less than negative 9 over 2? Well, there aren't any. No solution. All the natural numbers are positive. They're certainly not less than some negative number, right? Well, okay, moving on. Let's try this next one. I will subtract 8x, giving me negative 3x plus 1 is less than negative 5. I'll subtract 1 from each side. Okay, I'm dividing by a negative number, so I get x is greater than 2. So what natural numbers are that? So, well, maybe you wanted to just kind of write it like this. 2, 3, 4, 5, dot, 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 called elliptical notation. And hey, for now, I'm fine with that. You don't need to get too fancy with this yet. 2, 3, 4, as long as we can see the pattern is fine. If you want to be a little bit more formal, we would do something like this. We would say x such that x is an element. Cell sideways E means is an element of or is a member of the set in, and x is greater than, oh my goodness. Do you see my mistake? That's right. That's not right. Okay. Do you see it? What did I do? That number there has no business being in that solution set, because it is not greater than 2. I was thinking of greater than or equal to, and I didn't catch it, so I wrote it another way. All right. Whew. Okay. Your exit ticket today is to describe how does the number of solutions of 4x less than 8 over the domain of natural numbers compare to the number of solutions over the domain of real numbers. They are remarkably different, are they not? So think about that, contemplate it, and give me some feedback, and we can talk about it. But until I see you next time on our next lesson, please take care.